Greetings, everyone. Sorry about that long delay before I talked. I know that I am sorry I am not here today. I am out on a field trip. I totally forgot when I told you I would be here to go over especially the problems on the back side of the worksheet from last night. So you can check my answer key. It is on my desk in the purple folder, as all answer keys for your class tends to be. If you don't mind, I'm going to do a couple right now. Let's look at number 35. So 35 from the homework last night. It read log base 3 of 1 over 243. And I need to know what x is. So when I do that rewrite, remember that's going to become 3 to the x power equals 1 over 243. So the question becomes, is 243 some answer that is 3 to some power? So this is 3x equals, well, 243. To get that, remember, 243, to move him up, because my 3 base is in the bottom, is in the top. To get this to be a 3 up top, I have to use a negative exponent. And then on top of that, 243, well, what is that? Well, that's 3 to the 5th power. So this would be negative 5. So this is x equals negative 5. Let's look at, what else do I think it was kind of rough on here? It's really those problems. If you looked at, what's another one? Number 44. That was log of a base 7, 343. So this is 7 to the x power equals, well, can I get 1 over 343 to have a base of 7? That's my goal. Can I get 7 to the x power to equal the base of 7 to some other exponent? Well, 343, I know, 1, because I know, and 2, because I looked at, hey, I have a 7 here in my base, right here. This is a base of 7. So is there some exponent I can put on 7 that will eventually get to 343? And the answer is yes, it's 3. 7 to the 3rd power. So this guy right here, this guy is really 7 to the 3rd power. Well, 7 to the 3rd power is great. I have my base of 7, but it's still in the denominator, so we know that we have to move him up. We have to make that number negative, so x is negative 3. So if you have any other questions, as I said, the worksheet's in the purple folder. Please, please, please check your work. Let's go ahead and move on to today's notes. Well, maybe we'll move on to today's notes, if there are notes for today. Oh, they're way down here. Sorry. All right. We're going to evaluate common logs and natural logs. Now, common logs means if there is no base, and you know we love to do this to you all, if there's no base number, there's no b. If no b, right? No b. That is automatically, you know that's a 10. And that you can put this in your calculator. So what you would do is literally in your calculator, you will hit the log button. You will type in 5. You will get an answer. You are going to love today's worksheet. It goes very quickly because all it is except for some review problems on the back side, all it is calculator work. So in that lovely calculator of yours by now, you've put the log in, you've put 5, you've hit enter, and I want you to go out 3 decimal places. So this is 6, 9, 8, 9, which means when I round that, that is 6, 9, 9. That would be your answer. Natural log. Natural logs is taught when we're talking about E. A lot of you on your calculators will see that you have an E button. Natural log and E go together. So when I take the natural log, all you have to do is hit the LN button on your calculator, type in 0.1, hit enter, and you will get a negative 2.3025. So to round that properly, that will be negative 2.303. So once again, as I said, what this really means is we're talking about log, base 10, and natural log, which is the ln. Natural log is really log base E. But they made a button for that, which is the ln button. All right. Now, sometimes, and this is on this worksheet for today, we want you to be able to do, I asked you to find it, but I can rewrite this as 6 to the x equals 54, I mean, doesn't equal 54, sorry. Yeah, equals 54, sorry. There's no way I can ever get 54 to be a base number of 6 and find an exponent. It doesn't happen. So we cannot do. So what do you end up doing? Well, there's this thing called the change of base formula. And if you notice, we're talking about this guy here. We're going to call him A, even though I know we normally call him B. For right now, we're going to call him A. And we're going to call this spot here the X. And if you notice in our formula, we're going to put the X on top, A on bottom, and we're going to pick a B. So long as your base number is the same, you're okay. You can do the math. Now, let's be smart. What do we want our little b or our base to be? Well, we want it to be in base 10 because what? That's right. We can put that in our calculator. So the log of 54 base 6, we're talking about a here is 6, x here is 54. So when I plug that into my formula, I'm going to have the log of 10. Remember I said use 10. And we're going to put the x on top, so that's 54, over log of base 10 of 6. Now, all you have to do with that is put it in your calculator. How? You can do it in 2 steps, or you can do it in 1 step. So I would hit my log button. I would type in 54, so I'm putting into the calculator, calculator. That is a U, Colin, right there. It closed up on me. So I'm going to put the log, and then I'm going to put 54. I'm going to close that parenthesis. I'm going to hit divided by, and then I'm going to type in log, and I'm going to put the 6 in. So log 54 divided by log of 6 should give you in your calculators an answer of 2.226 if you round it correctly. So you are evaluating your logs today. You are going to be using bases. You're going to use the change of base formula, and you are good to go. So all of this is calculator drill. It's just some of them you're going to have to use this change of base formula on. All right. Thank you for watching this. Have fun with your worksheet. Okay, I know you won't really have fun, but enjoy the fact that it will go very quickly for you because it's just calculator drill. All right. Talk to you tomorrow.